Okay, and so we're on to our last type of transformation, and this is stretching and shrinking. And so let me kind of give you a very general representation of this, and then we'll talk about it specifically. So if you were to pull up a picture on your smartphone or on any sort of touch screen, so let me pull up a picture of my daughter here, my favorite picture of her newborn. I can stretch this and I can shrink this. So just like zooming out and zooming in, I can stretch it, I can make it bigger, or I can shrink it. I can make it smaller. So this is what we're talking about, stretching it and shrinking it. But the difference between just generalized stretching and shrinking as pictures as opposed to graphs is when I stretch it here, it keeps my proportions the same, meaning it stretches it in the same horizontal and vertical distance. It's keeping my rectangular shape in the same shape or whatnot, in the same measurement. Okay. When we do this on graphs, we won't necessarily be doing that. We can stretch it vertically and shrink it horizontally all at the same time. So that is the difference between just zooming in and zooming out. Stretching, just like you think. Stretching the graph, shrinking it, smushing the graph. Okay. So another way to visualize this is if it's vertical, we're going to stretch it away from the x-axis. That's a stretch. If we shrink it, we smush it towards the x-axis. Horizontal, same thing. Away from the y-axis if we stretch it, towards the y-axis if we shrink it. And so again, let me get my Desmos app up here, and so you can see how this works. Okay, so I have my basic graph here, and so let me start the actual stretching. So you can see that this is a vertical stretch. It is vertically stretching it away from my x-axis. So it's stretching it in this fashion. So this is the biggest stretch, and then this one here is my original. So stretching it away and then back to my original. So that's a vertical stretch. Let me pause that one. Okay, let's go to a vertical shrink. So this is shrinking it, and then this is my original right there. And then back to shrinking it. So again, notice we're smushing it towards the x-axis. Okay, same thing, we'll just show you all of these here. Horizontal stretch is stretching it, okay, away from the y-axis, so stretch. Back close in is the original right there, and then it's stretching it horizontally. So we're pulling it this way. Okay. And then the last one of these I have here. Get all these turned on. So this is smushing it towards the y-axis, and then now out is my original, and then a smush. Okay. So if we wanted to see these in standard where they're not moving, I can show you all of them at the same time. So this is my original, is the red. The orange is smushing it, so there's a smushed graph. And then the blue is a stretched graph. So this one is in the horizontal fashion. And let me do the same thing here. So this is my standard in red. Orange is a smushed graph. This is vertical. And blue is a stretched graph. This is horizontal. So you can see how all of these, this is vertical. So you can see how all of these things happen. Okay, let's see how it actually looks in our function format. So I'm going to talk about vertical first. We should know vertical is happening on the outside. So we see that this value is happening on the outside. Okay? If our value is a number that's larger than 1, so think of a big number. If we multiply it, notice this is a times f of x. If we multiply it, then we're going to stretch it. If our a is between 0 and 1, so think of numbers between 0 and 1. 1/2, 0.25, 1/3, 0.8762. Those are kind of small values. So if you're multiplying by a small value, you're going to smush your graph, and this is vertical. Okay. So the way that we would actually transform these graphs is we would take these y coordinates and we would multiply them by a, because that's what's happening here, is a times f of x. Now notice up here that these are only talking about the positive values. Well, what would happen if we're talking about the negative values? Well, we already talked about the negative values. If a is less than 0, meaning we're going to multiply by a negative, we already know that if we multiply by a negative, that's going to reflect it. So we would reflect it and smush it, or reflect it and stretch it all at the same time. So that's how vertical works, and so let's go back to our image here. This is vertical. So notice in my blue, I have a large number, something bigger than 1, multiplied by it, so the blue is the stretched. Notice in the orange, I have a fraction between 0 and 1, or decimal, multiplied by it, a small number, so I have it shrunk. So the orange is shrunk by 3 units, and the blue is stretched by 3 units. Let's see how it looks when we're doing horizontal. Same things here. Notice C is larger than 1, or C is between 0 and 1. Notice where our C is. Our C is on the inside of the function. Inside is happening horizontally. So inside horizontally, but backwards. If we have a large number, that means we're actually smushing it horizontally. If we have a fraction in between 0 and 1, that means we're actually stretching it horizontally. So when we actually have to transform these graphs, instead of multiplying it like we would assume, we're actually going to divide those x coordinates by that value. And same thing, if C is negative, we're going to reflect it. So let's see the image of this one. Okay. Notice here, when I had a large number on the inside, that actually gave me my smushed graph. When I had my fraction between 0 and 1 on the inside, that gave me my stretched out graph. So we can see that this one is happening backwards. All right, so let's actually do an example that goes with this one here. So I have f of x is equal to 3 times the square root of x. Pause the video and figure out the basic function, the transformation, and then graph it using that information above. So our basic function is y equals square root of x. We only have one transformation here. I was trying to give it to you easy, so we have a 3. The 3 is multiplied. If it's a multiplication, that means we're stretching or shrinking it. It's on the outside. So outside is happening normally. So it actually means we're going to stretch it vertically by 3 units. So let's get my basic graph here. I've got my key points. And I want to take all of my y values and I want to multiply them all by 3. So if I take my y value of 0 and multiply it by 3, it still gives me 0. If I take my y value of 1 and multiply it by 3, that gives me my y value of 3. If I take my y value of 2 and multiply it by 3, that gives me 6. So here is my transformed graph. So notice this graph is stretched vertically by 3 units. Okay. I can also talk about domain and range and intercepts here. My intercepts, both of them are still at the origin, 0, 0. My domain and my range actually stays the same because I did not reflect or shift this. Okay, let's look at a second example, which is almost the same thing. In fact, at first glance, you might even think it was the same thing. But notice my last example had the 3 on the outside, and this example has the 3 on the inside. So pause the video and you can see if you can figure out what this one's doing. Okay, same basic function, y equals square root of x. This one, the 3 is on the inside. So inside means it's going to do it horizontally. It's still multiplied, so that means we're still going to do stretching or shrinking, but inside is going to do backwards. So I'm not going to actually multiply it by 3. I'm going to divide it by 3. So that means I'm going to shrink it horizontally by 3 units. So key points to my same basic graph. And now I'm going to take my x values and I'm going to divide them by 3. So my x value of 0 stays 0. My x value of 1 divided by 3 becomes 1/3. My x value of 4 divided by 3 is 4/3, or 1 1/3. And if I wanted to take another point, if that wasn't enough, I could go out to the next key point would be 9, 6, 7, 8, 9, and then 3 would be my next point on this graph. Okay. If I divided that by 3, that would give me a 3. So that would give me this here. So here is this graph there. Now, if I were to ask you what happened to it, you might think it actually stretched vertically, just like the last graph. But notice it's not. It wasn't stretched vertically. We actually smushed it horizontally. And of course, you can always double check these by graphing it in the graphing calculator. X-intercept stayed the same. Domain and range also stayed the same. And so at this point, we have identified all of our transformations. Shifting it is addition and subtraction. Reflecting it is multiplying by a negative. And stretching and shrinking it is just multiplying or dividing by a number. And so in the next videos, we're going to be working on recapping all of those at once and looking at different types of examples.